Okay, so the purpose of Fade is to address a growing problem with the browser, and that is that the browser, as it is becoming ubiquitous, is starting to underserve the needs of what we're using it for. It was originally built on the premise of serving up documents and media. And in fact, HTML, that is its stated purpose on the Wikipedia page, to serve up documents and media. It does not, however, serve up web applications very well. It has a lot of issues in that regard. And so one of the issues with that is that all of these frameworks are now popping up to say, okay, how do we solve this common problem we have? How do we deliver web applications to every device? Some people take the approach of, well, we're going to build a simple web app and then maybe have mobile apps, or then have ways of getting the more advanced features on devices through application development. But I think we should push for a hybrid approach where we have a full-featured framework that serves all of us. So the taglines for this is develop everywhere, publish everywhere, XAML everywhere. So on the agenda, we're going to talk about the state of the browser, current advancements, and then how we're going to move forward, and some challenges, and then we'll finish it off with some demos. Okay, so in this picture, this donkey represents HTML and CSS. It is wildly overwhelmed with trying to handle a load that it just cannot handle. The main issues that I'll go over is complexity, context loss / what I call bleeding. It's very restrictive. It's fragmented. It leads to a fragmented library system, and it's inconsistent. So I'm going to break a cardinal rule of presentations and read directly from the slide. CSS, this is a quote from Brett Victors, a famous researcher in UX and web application design. CSS, a language for specifying visual appearance on the web, is so complex that it has never been implemented correctly. Yet successive versions specify even more complexity. At the same time, it is so underpowered that many elementary graphic designs are impossible or prohibitively difficult. And context sensitivity, or anything computational, must be addressed externally. Most CSS lore is dedicated to describing the tangles of brittle hacks needed to circumvent incompatibilities or approximate a desired appearance. One cause of the CSS mess is the eschewing of elegant, flexible abstractions for 1,000 special cases, a detrimental approach which precludes simplicity and generality in any domain. However, the larger and more germane fault is the language's attempt to serve as both tool and platform, thereby succeeding as neither. This I probably could have grouped under more than just complexity. This sums up all of the complaints that I have with HTML and CSS. Complexity, losing of context, trying to code for the special case, when in fact a platform should serve a general case rather than one particular instance. And one example of this is if you go and look on GitHub and you search for all files, CSS or HTML files containing the word hack or fix, you're going to find millions and millions of results. I think this is a testament to the state of affairs with the browser, and it is increasing the cost of development, the cost of ownership, and making it painful for us developers to build what we want to build. On top of that, because everything is global, both in all three aspects, in JavaScript, CSS, HTML, you get this situation where you get a collision syndrome. If someone builds something and someone else names it the same thing, you collide. Well, now, how do you resolve that? Well, this leads to a context tug of war where you start coming up with different ways of naming things. Okay, maybe you put it in a module. But the problem is that if you ever need to talk between the modules, you lose context. So what do? You expose certain pieces, and it's exposed back into the global world, and you start clobbering yourself again. And this context loss becomes bigger and bigger as we get into web applications from websites. On top of that, it's very restrictive, and I'm speaking mainly in terms of HTML and CSS here. JavaScript allows us to do polyfills, but in a sense, you're actually globally clobbering everybody when you're doing those. So they are dangerous. But in terms of HTML and CSS, there's really no good way to extend the DOM. And on top of that, As a result, you get vendor lock-in. And this cat represents every web developer out there, because we are locked in to what the browsers and the standard specifications are telling us what we're allowed to do. Between Google, Microsoft, and Mozilla, they've told us through their they've implicitly told us what they're going to build. And if they don't build it, then we don't have that functionality. And so what ends up happening? We have to build these libraries that are kind of tack-ons to address the situation. And once again, as we scale to larger and larger web apps, this becomes a bigger and bigger problem. The next thing is both a good thing and a bad thing, I think. The state of the JavaScript community is that there are many, many libraries out there to solve things, which means that it's a very robust community. There are very many people involved, and they really want to see this this environment, this ecosystem succeed. The problem with it is that no one has come around and given a standardized way of carrying out these functions, carrying out these features. And so what you get is all of these libraries doing things a totally different way. And if you want to include them together, you have to worry about compatibility issues, both between browsers and between libraries. And sometimes the libraries are doing the same thing, and so you're getting this, everybody's walking on top of each other. And so this fragmentation approach is starting to, I think, collapse on itself. On top of the fact that all these libraries are very inconsistent how you use them. You have to go research how every single one is included, how every one is used. If you want to use them together, you want to integrate them together, like I said, compatibility issues are rampant. So this is my general idea of how a cost versus feature spectrum would go. HTML becomes exponentially expensive, both technically and financially, when you start increasing features and increasing the scope and size of your application. Angular, while addressing the problem, still has a little bit of a exponential spectrum to it. While the approach I'm going to show you today has more of a linear approach. It doesn't increase exponentially over the features or scope of your project. So how do we need to solve this? We need to make sure that a framework is simple, has a flexible context, but is isolated. We want to be able to extend whatever is built for us. It needs to be uniform and consistent. Okay, so how are we going to do that? Well, what I've just described for you is the solid principles. For those of you familiar with solid, they are a set of 5 principles which were described for object-oriented programming. Now, the point of all these principles is to put you in a great, to give you great code quality and to help you build features faster and faster. As you increase your scope of your application, if you do not follow these rules, you're going to start incurring so much technical debt that you'll start tripping over yourself. And so what I've described on this previous slide is sort of a restate of all of these principles. The 2 most important for Fayde are the single responsibility principle as well as the open-close principle. Now, the single responsibility principle is an illustration that we want to make everything we build needs to serve one purpose and one purpose only. So in the case of HTML, we usually have divs, and divs are everywhere. They do everything. That is a huge violation of the responsibility principle. So what I'm going to show you partially today is how we're going to isolate what our objects do, and we're going to make them do only that. The open-close principle is more of our context bleeding, where we want things to be open so that people can change them and integrate and work with them, but we want them to be closed so that we're hiding context where people should not be touching. So we'll go through a little bit of that. Now, the current approaches, I've listed just a couple of the many approaches that people have taken to address web applications. The first one being jQuery, which is very, very popular. It's been around for a long time. The first goal for that was just to make all of the browsers communicate the same way. How can I do the same thing in every browser? It did help simplify many, many of the problems. but it was, like I said, it didn't solve the entire problem. Now, Angular comes around and they say, okay, we're going to change up the game. We're going to include dependency injection as our core tenet. That way we can make everything testable. Now, they did address that in a way that they're able to isolate things and make them extensible. They're follow some of these solid principles. The problem with it is they didn't go far enough. They have stated many times that they don't want to touch HTML. They only want to plop on top of that this framework to address web applications. Now, I personally think that HTML and CSS are the sandy soil at which our web applications are sitting on. And so while Angular does address things very well, and I absolutely love it because it's gotten us so far, it's only a stepping stone to get us further. It is not the end goal. There's so much more we can do, and I want to push the boundaries of what we can do. So how is Fayde going to solve this? Okay, the first thing it's going to do is provide you with a pattern called MVVM. Now, most of you, if you know MVC, it's very similar. However, the difference is that in MVC, the controller controls the view. But in MVVM, the view model, which is an equivalent pattern, does not control the view whatsoever. In fact, one of the main things when people are teaching you MVVM is that you should never, ever, ever touch the view when you're in the view model. You should never even think about it. In fact, most people say you build your view model and unit test it, and then you build your view. In fact, before, in older XAML frameworks, there's actually prototyping tools where a designer will go off and build the view in XAML. The developer will build the view model in C# as it was, but now it will be in a new language. And they would meet together, and as long as they agreed on a contract, then both of them could get their job done and integrate properly. Now, the way we're going to go about doing this is the core feature of Fayde, and that is the layout and render engine. What it's going to provide is that no matter what you build in your view, it's going to look the same everywhere. On top of that, we're going to make sure that because we're isolating our responsibilities, you're going to be able to compose your applications using all of these different pieces and functionality. Rather than building one monolithic control that does everything, you're going to compose controls and compose the application. As a result, this allows us to both to inject dependencies into the view, which Angular does not support. They are able to inject things into the code behind and all your logic, but it's very prohibitive to inject things into the view. And I'll show a little bit of that, what I mean later. On top of that, because HTML, once you move things around on the page, they start colliding and clobbering. Things start looking different when you move to different sections of the page. XAML provides a way of plugging and playing, if you will. So when you move things around the page, they're going to work the same as they did before. They're not going to start getting confused based on the context they're sitting in. On top of that, things are going to be reactive. Every element in XAML is reactive. It always provides some type of change notification. Whereas in the DOM, you don't know if things are changed. You kind of have to poll for it, or you have to run a digest cycle, or you have to have some way of knowing. And that all is built into the framework of Fayde. Now, the challenges going forward that Fayde needs to address is there needs to be more tooling. We need more adoption. There's performance issues that we need to address, as well as we want to build themes that out of the box, Fayde just looks great. Now, all of these are very accomplishable problems. In fact, I have, specifically for the performance, I have tasks that I need to carry out to address these. In fact, anybody can pick them up and run with them if they want to. So I'm going to show you a few demos. Okay. The first one I want to show is sort of a test bed, a sandbox that we used when we were developing Fayde. Initially, we actually toyed with the notion of putting Fayde on top of HTML and letting HTML do the work. But what we found was that this test bed, this sandbox, was actually totally impossible in HTML. What we found is that the more code we introduced to take care of the edge cases, we actually started introducing more problems. And so just as Victor said, it became prohibitively difficult the more and more we tried to do. So this kind of illustrates just on the surface, some of the things we did. Now, the next demo I want to show is this is um, an Angular version of this to-do MVC, which is sort of a demo of how you can run MV star frameworks. And so in this one, you can type in to-dos, and you can say, okay, I need groceries, and you can check them off and everything. Well, I want to illustrate that we can do the exact same thing in Fayde. So we can say, okay, I need groceries. What kind of groceries do we need? We need maybe bananas, apples, oranges, and um, we can do all the things that we could in the other one. So we can say, okay, we already got the bananas, apples. We already have the oranges. Or we can toggle them all, just like the other one. So I do want to illustrate that Fayde is at a point where we are at the level of HTML+. We are already surpassing it with our development. The next demo I want to show is more and more involved into web applications. So this is a demo timesheet app where you can input entries and edit your values for your entries, and it automatically reacts as we see through these bindings here. The revenue is automatically increasing. Now, this is not fully featured. This is a very quick demo that I put together. There are many places I want to take this to make it to show off what I can do, but I did want to show that this is something that is very common in web application world, and I wanted to show that we can do this. We just need to go further with it. The next demo I want to show is a drawing pad. So we do support multi-touch. So I can click, and it actually supports multi-touch, but right now I'm just doing an emulation of the touch screen. And so we can do all kinds of things on this. So we do support multi-touch. And we're actually furthering that to support multi-touch with all of the controls that we're building. The next one is a map. And what I want to emphasize here is that Fayde is a vector graphics engine. That means that whatever is drawn can be scaled up and down. And so this is an SVG set of paths that you could draw in HTML using the SVG. The issue is that with SVGs, you start to lose some of the functionality of HTML, whereas in Fayde, all of the full functionality that exists across the entire framework still exists. I can still mouse over these. I could add tooltips to this. I could add all kinds of mouse gestures and touch gestures and all this other functionality that you would not get with SVGs. The next one is an even larger app that we started building a while ago. This one illustrates a fantasy football draft. So the way the fantasy football draft works is at the beginning of a season, you get together with the people you're playing with, and you choose real-world players, and you draft them. And so what we see here is there's actually a countdown clock, and we set it at 10 seconds just to test what's going on. And so every 10 seconds, one of the teams listed in here, the top team, is going to choose a player. And so we can see how we're able to choose players over time, and this illustrates a real-world example of what we're doing. On top of that, we actually have a chat box over here. Now, most times when you have a chat box, a lot of times what you have to do is you have to say, okay, I'm actually pressing enter right here. Most people, when you build things like this, you say, okay, I need to respond to the click event on the checkbox, and or rather the key down event, and when I pressed enter, I want to make sure that I do all this work. Well, this interaction is injected dynamically onto the text box. So I created a behavior, and the behavior's purpose was every time someone clicked enter on whatever element I'm attached to, I'm going to perform an action. And I then bound that action to my view model. And so when I do stuff here, I am in no way, I'm isolating everything, yet exposing only the context I need between the three elements. Okay. The last one I want to demo is sort of a play app, sort of a test bed as well. What I want to illustrate here is that what I mean by extensibility and isolating things is that you can do things you could not do before. One of them is a button. So when most people think of a button, they think of a visual element that sits on the screen. And is clickable. The problem with that notion is that, well, there's a lot of things that are visual elements. Why does a button have to render a certain way? Why can't it render many different ways? So in this case, I've actually created a button here that has a panel in it, which has an image and a text block. So I've changed how the button is going to render just by including in its content, just by swapping out. And so the button's only responsibility is to click. And when it clicks, I want to do something as a result. The other thing I want to illustrate here in this demo is that these are all text blocks that are aligned both vertically and horizontally. This is not possible in HTML without hacking it or trying to set absolute values or trying to toy with it a lot. This is merely a matter of just saying vertical alignment equals center, horizontal alignment equals center. Very simple properties which help accomplish a very, very easy goal. The next thing I want to illustrate is this text block right here. So in Fayde, there's a notion of a brush. And a brush can be solid, it could be a linear gradient or radial gradient. So what you see here is this is actually a linear gradient. And there's two things going on here. First of all, you can apply a brush. Wherever a brush is used, you can apply any of the ones that you code. In fact, you can even throw in your own brushes to brush them however you want. And so right here, I'm illustrating that I have these gradient stops running from red, orange, yellow, green, blue, and purple. And they're running on a relative scale. So what I'm saying here is start from the left and go to the far right and draw. So if I change the font size, it's going to still draw from left to right, from the very, very start to the very, very end. So I can show how just a quick change, and they're still drawn the same. I can change it lower, and it's still drawn the same. Okay, so I'd like to open up to questions at this point. Anybody have any questions?
I guess the first one would be the first test site that you had. You said that there are things that aren't possible in HTML. I was just wondering if you could call out one or two examples of that.
Sure. So this is what you call a grid-based layout. There's actually something in the spec in CSS3 to build this particular situation, where the way it works is you can specify three types of values for both column definitions. And the first one, actually just pull it up real quick so I can illustrate. So the first three, these are the column definitions that we've established here. The first one is saying 500 pixels. So this one's always going to be 500 pixels wide. The second one is, if it's not specified, it's called a star, which is kind of a percent, but it's not a percent in like 100%. It's more like if I specify 3 stars, then each of them are going to take up about 33%. So what ends up happening is if you resize this, you'll see that this actually will grow based on whatever content is left. This furthest column is called auto, which means whatever is in my contents, I'm going to take up and then let everybody else have the rest. The new spec does call for this, and it is coming down coming down the pipeline. The problem is that even when they build this, it still won't be possible to include some of the elements in here that we're doing. So, I don't. Does that give enough detail for you?
Yeah, I think especially just the ease in which this is kind of built in.
Exactly. Yeah, the other thing I will show as well is I spoke briefly about how there's dependency injection, and one of the things I mean by that is we have the notion of what's called an attached property. So right here, we're actually telling the border to sit in the first, or rather the second column of the grid that it's contained within. And so what you can actually do is you can actually span these across multiple columns as well. So the minute I change that, wait, which element was that? Oh, that's probably a bad example. Let me choose a better one. Let me choose this one. Is this the right example? Let's see. Let's choose hi, I'm a text block. Okay, right here. Let's choose this one. So I'm going to make this much wider. And I'm going to put it on the first column. Okay, so this one you see actually spans 2 now. You actually can't do that in tables at this moment, and until grids come out, that won't be possible. Even when they do build it, like I said, because of the fact that this grid.row is an attached property, it's not built into the engine, it's built on top of the engine. And so you could change it to work however you want. You could build your own. Whereas in HTML, you can't do that. You have to rely on whatever the spec says. Make sense?
Yep.
Great. Anybody else?
If I can ask another.
Sure.
So you said that this is SVG based. Are you using the browser SVG rendering, or is it Canvas? I think when I saw the prototype a year ago, it was Canvas.
Right. Yeah. So this is all vector graphics. It's not SVG. It's all done on the canvas. Yes. So.
Okay. And then to follow up, then, are you repainting when there's new things to draw, or is it refreshing like 60 times a second, no matter what?
Right. So there is a refresh every 60. Well, it's actually using the animation frames, which is it's between about every 16 to 33 milliseconds. It does not repaint everything every single time. It's not like a video game engine. What it does is it actually selectively optimizes what it's going to remeasure and repaint using a tree algorithm. So if it notices that nothing in maybe, let's see, let me turn on something real quick. So if it notices that everything right here doesn't need a repaint, it'll just prune all of the items underneath that tree element and not even go to repaint it. It'll just skip over it totally. Make sense?
Yeah.
Okay.
Well, with the canvas though and the HTML, it would redraw the whole thing, but when you're doing the calculations, it'll only be for that one part, right?
Exactly. Yeah, so what I'm looking for...
Okay.
Go ahead. Good.
Oh, keep going. Sorry about that.
No, go ahead.
Just curious how you're handling things like scaling on when they resize the browser.
What do you mean by scaling like resolution or scaling like performance?
Like resolutions.
Okay. So because it's vector graphics, again, when you scale, everything scales with it. Everything is somewhat pixel independent until it goes to paint. Does that answer your question?
Yeah, it does.
Okay. Anybody else? All right. So what I'm hoping to accomplish out of this is to build a community of people that are really interested in building on a philosophy. Like I said, building in a framework that really serves the needs of web applications. And I actually have on our website, I have a bunch of. Let me turn off annotations. On our website, there's actually a link to our Trello boards. Pull those up. Oops. And if you go to the roadmap, there's a list of a lot of things that we need help with. Some of the most important ones are we really want to gain more adoption and get people interested in this, and so we're trying to get documentation. We're trying to build our own theme libraries to, right, like I said, right out of the box, it looks great. We're trying to expand what it can do, building like charting libraries, like data visualization. We have some great ideas around like making a hybrid of D3 and blending that with like a high charts or one that's like a prepackaged charting library. We want to blend those two and get the best of both worlds. So we have a bunch of things to pick up, and on top of that, fixes. We have a clear roadmap for some of the performance issues as well. So I'm really looking for people to get involved in any way. So if nobody has any more questions or suggestions, we can finish on that.
And how large is the current team that's working on it?
Right now, my brother and I are the two main contributors. We have a few other people that are coming in and out of the project contributing. One from Australia, two from the UK, one other from Indiana, but it's not full time, like full contributions like we're making. So. Okay, I guess we'll finish on that then. Thanks everybody for coming.
Thank you.
Yeah, thanks so much. That was really cool.
All right.
Actually,
thanks.
hey, can you go back to one more? Oh, this is awesome. Not this. Go to the sports thing again. That was awesome.
Okay. Oop, come on.
Oh, look at that. Come on. So is this all updating in real time? What data are you using for this?
Well, this is like it's not hitting a server right now. We decided just to make it really, really simple, so we didn't have to hook any servers up to it. This is just a client-side demo. So.
What's the performance like if you're hitting a server for something like this?
I don't think it'll be much different. It's downloading all of this data to start with when it goes to load the application. So if you were loading it through a source, it would just rely on how fast your server is at that point.
Are you using like observers and stuff to update the data, like if it was coming in real time, or how are you doing that? Yeah.
So one of the fundamental tenets of MVVM is that everything should be reactive. Everything should be notifiable. What I mean by that is, when you hold all of your data in a certain data set that exposes a contract called property change, and anytime data changes, you fire off an event, and XAML, the engine, knows to look for those contracts, those notifications, and will respond to them accordingly. And so when an item, what's happening here is when someone gets drafted, we're not doing anything in the view. We're actually just taking an item from one data set, moving it into another, into this draft history, and the rest of the UI updates accordingly. Anybody else?
So when you end up capturing what the SVG is supposed to be, and then you go to draw it on canvas, and when you're actually calculating what pixels are colored, are you using some kind of library that already existed, or is that all done by hand?
No, this is all done by hand. I have the canvas exposes a few set of things. Most of them are based around text and lines. So you can draw. Actually, it's really around paths. So if you're familiar with a path can be can consist of a line, an arc, a lot of different smaller elements, and when you draw them all together using a brush, you can get a lot of these visual elements that we're showing here.
Okay.
Hey, how compatible is it with like XAML? Like if you were to take a current XAML application?
There are a few differences between them. It is we actually have the guy in Australia that's helping out is actually converting his application from Silverlight to Fayde here, and it's close enough to where the pains of converting it are minimal compared to what it would cost to migrate to an HTML application. Anybody else?
I know it'd be like way down the road, but do you have any like thoughts around how you do accessibility?
So that's actually something I probably should have brought up. By nature, view models are testable immediately. On top of that, what you would call the DOM in HTML, you would call like XAML in this framework, and XAML is actually a state-based configuration. So what that means is I give it state, and it knows how to draw accordingly. And so you can actually test your entire views, unlike anything else in HTML. You can actually test your views without using a browser. You can do it using Phantom.js or any headless JavaScript, like maybe even Node.js if you wanted. Anybody else? All right. Well, if you guys think of any questions or anything afterwards, just send me an email.
Awesome. This was really nice, man.
Cool. All right. Thanks everybody for coming.
Thank you. Thanks.
Thanks so much, man.